Hello students, we're continuing to discuss the neuron and the generation of the action potential, that generation of the electrical impulse that travels along the axon of the neuron. And in this segment I'd like to talk about what are called refractory periods. And a refractory period is a time period in which the neuron cannot be stimulated again. And we're going to have two refractory periods, an absolute refractory period and a relative refractory period. We'll talk about the absolute refractory period first. And again, so the absolute refractory period is a period that neuron, no matter what kind of stimulus I give, the neuron will not fire again. The neuron cannot be stimulated again. This is very important for two reasons. One, it guarantees that all action potentials have an all or none response. It means that action potential, I cannot put one action potential on top of another action potential. The action potentials remain separate. They all remain the same size, and it also makes sure that they all go down all the way down the axon. The other really key thing about the absolute refractory period is it enforces one-way transmission of nerve impulses. It ensures that a nerve impulse can only travel in one direction down the axon. So if we take a look at them, here is our action potential with the depolarization, repolarization, hyperpolarization. Here's a stimulus that causes that action potential. This period right in here is the absolute refractory period. Once I apply this stimulus and create this action potential, if I apply another stimulus, it will not create another action potential. It will not add on to that action potential. Also, as the action potential is moving down the axon, what will happen is that the area of the neuron directly behind the axon will always be in an absolute refractory period. That means that the action potential can only open voltage-gated channels in front of it, not behind it, because behind it, those voltage-gated channels, they're not responsive to any stimulus. I cannot create an action potential immediately behind a currently traveling action potential. And so again, this absolute refractory period of time in which another stimulus will not create another action potential, absolutely important for one-way propagation of the action potential. And then I also have this relative refractory period. During the relative refractory period, this corresponds to the period of time in which that area of the membrane where the action potential has just been is hyperpolarized. It's a little extra negative. And in this case, I can create another if I have an extra strong stimulus, I can create another action potential in this area. And so in that case, this is a way for the neuron, if the stimulus is strong enough, to still respond. And so again, in the case of the relative refractory period, that is the period in which an exceptionally strong stimulus may generate an action potential. Thank you.